recording. This is more 3D printing. So we talked about laser cutting, but how about 3D printing something? I'm gonna just leave that there and just go to something that makes more sense to 3D print. Yeah, well, one thing I forgot in the previous laser cutting is that obviously you're not laser cutting the project. The project in Rhino is a real scale. So it's like, 60 feet. Obviously you can't laser cut this. So there's an issue of scale factor for every single line drawing. That kind of makes sense. And I hope it's clear. Just keep in your mind, you can't laser cut a real scale house, for example, because that would be building a house. No, okay, so we need to reduce scale, maybe 10 times smaller, whatever it is. And to scale, you use the scale tools from Rhino or from AutoCAD. Scale down 10 or 0.1 factor, 0.01 factor, whatever it is that is ideal for you. Okay, now in terms of 3D printing, I would recommend if you're going to 3D print that it makes sense that you 3D print. I talked about it in class already, but a project like this is very difficult to laser cut, if not impossible. So that's when you start thinking, we might need to 3D print this if I have to show it to a client, if I have to show it to my professors, whatever it is. No? And again, the same as laser cutting, you need to consider scale. You could 3D print the whole building, but that would require specific machinery that doesn't make sense at this given point. So we need to scale this, and I can talk about scaling and think about how you would have scaled the laser cutting model as well. So the typical is scale, obviously select the model. Point of reference, I always recommend the 0, 0. And then you can do 0.01, for example. And if that's a factor of reduction of 100%. No, so you could do that, which is factor based, or you can do a scale. Select your model from the 0, 0, and then you say, why not this dimension in whatever other scale I'm dealing with? I'm going to do 1/4. I'm going to do 1/16, whatever it is. You say from here, and you give a new number. Let's say this is, I don't know, let's say 6 inches. There you go. No, so now the distance from here to there is exactly 6 inches. I'm going to go do it again, Control C. Again, if you know one dimension precisely of one of the sides or one door, one stair, you can always scale your model, enter from this, and it's a reference scale. So you say from here to here, this is the dimension I know. Let's imagine it's 6 inches. Reduces that dimension exactly to 6 inches. And this is the thing, maybe a 6-inch 3D printed model. Maybe it's a little bigger, maybe it's a little smaller, whatever it is, but that it makes sense. Again, we can't do the entire building. No? So after scaling down, that's when you will do the laser cutting process. But you can scale down the drawings, if you create the exploded elements, and you can scale down by factor or by dimension, also the lines with no problem. Okay, 3D printing, it's an issue of meshes, as I talked about. So in a way, you need to actually do a mesh of this. So to convert the nerves, which is what we have, to a mesh, this is the thing. Now, before you do a mesh, just make sure this is the model you want. It's good that there's a closed poly surface. That means that it's in good shape. And then you do a mesh. No? We talked about mesh to nerves, but now we're doing, this is a nerves, and we're going to convert it into a mesh. There are many ways to transform a nerves into a mesh, and there are many aspects that you can do. You can do a simple controls, and just think of the more surfaces and curves that they're regular, the more polygons you need. If it's very blocky, the less. Let's say it's mostly squares, then probably doesn't make sense to the 3D printing. But if it has mostly squares, but just a couple of curves, so you might want to stay in the middle or something like that. If there's a lot of curves, that you might want to come here. I'm going to stay in the middle. And I'm going to do it several times so you see the difference. This is my first mesh. Notice that what it tries its best is to create triangles and polygon surface to accommodate it as best as possible to the geometry that you have created. If I select it, it says close mesh. So this is in good shape, I would imagine, for laser cutting. Let's do another mesh with a lot of surface, polygon surfaces. Notice how these are much smaller. Triangles are smaller. That means it's better resolution. Let's put them together so you can see. So smaller polygons when there's curves, bigger ones. So that means better resolution, but maybe it's a model that is so small it doesn't really matter. Depends also on the size, no? And I'm going to do now a mesh with very little polygons. There you go. They're even bigger, but you can tell how the curve is very chunky. So for this type of project, I will probably go with this one. This is the middle ground, and probably I will always go with the middle ground unless it's very softy and so on. I wouldn't go with that. Although this one obviously looks very good as well, but you can go with that one. It will take less time for the 3D printer to reprint and so on. Okay, so you need this guy. Put it back to 0. And this is a mess. And now the things that we need to do is to triple check that it's in good shape. And again, you need to talk to the manager, or Cave has a particular web page maybe that tells us, hey, our 3D printers are this type. There are hundreds of types of 3D printer machines. The ones we have several of them. So maybe some of them allow for some detail level. Other ones are bigger. They have a bigger bed that you can put a bigger model inside, et cetera, et cetera. So it depends on the 3D printer. You might be able to do some things or not others. So I'm going to talk more in general, and then these details are more to be discussed with the 3D printing manager, which is, again, in this case, Drake, but it could be a different person in the future. Okay, so the way to go is mainly mesh tools and start looking at these two options, which is mesh repair wizard. You click on that option, you check mesh, select the mesh, and if it says it's a good mesh, you're in good shape. Okay. If I intentionally delete a couple of those guys and I check mesh, it's still good to say. So I don't know at what point it will say it's about mesh. Maybe here. Well, I guess that it's not gonna tell us very nicely. In theory, we'll do an analysis and it will, let's see. That can't be a good mesh, obviously. What it says. Research. So it still says it's a good mesh. So I guess there are two things. One is good practice. The other one is trusting Rhino into doing things. Obviously, this, the one that we're dealing with, is not a good mesh because it's all open here. It's not watertight. But what my guess is that Rhino would be able to fix this, but obviously not fix it in a way that it will return. The 3D printer will not return the model to us as we intended to. So be careful with trusting. The first check of all is always make sure there's a closed mesh. Okay. The second, if you have minor problems, is to check the wizard, check the mesh, and if it says good mesh, you're in good shape. But I would nevertheless triple check that things are closed, that are looking fresh, et cetera, et cetera. So my guess, for example, is that this is not something that will be possible to 3D print because it's so small. So what you could do is things like Control Shift, start deleting some of these guys and fixing these elements. the way you can do this is by, for example, fill a mesh hole. There you go. And many times you're going to have naked edges and things like that you can also fix in different ways. You can basically weld the mesh, which is to join all of the meshes together. And in general, there are many tools that allow you to fill holes, to fix things, and to see if it's in good shape. Hopefully the model is so clean that you can just send it with no problem. No? Okay, so you're in good track. Again, there are many tools. Maybe this is a bit more specific depending on the problems you have. It's good to also check the dimensions of your model by doing bounding box. And basically enter, and it will create a box around the project or model, and you can just start adding under the drafting a couple of dimensions as we have done in the past. No? So that's 0.5. I believe it's in feet, so it's like 6 inches as we know. And 55. So you also can get the vertical, of course, as we've done in class. Great. Now, why then the dimensions matter? Because again, the 3D printer is like a little box, and it's a machine that what it does is pours liquid, a particular mass liquid, X, Y, X, Y, X, Y, and then goes up X, Y, X, Y. So it only can develop models or a particular size that fits into that box. So that's another thing that you can talk to the managers, like how big can my model be? You can always 3D print 2 pieces and put them together and lock them somehow. Okay, so if you check the dimensions, you can tell the manager, am I good, kind of thing, and they tell you, yes, you can perfectly 3D print this. You check your mesh as we did a little bit. It's a closed mesh and it looks fresh and nice. Then you're good to go. What does the manager need to 3D print? Well, you need to export it as STL. Here, STL lithography model, export it to 3D print model. Okay. Okay, well, you will have this guy. This is how it looks. This is the model. You need to send or to the manager, 3D printer manager, hey, is it working? Now, it might be that you can actually access the machines yourself and introduce this file, most probably through the web. You can send it, and I think there's some settings that you can place yourself. Maybe before you do it the first time, triple check with the 3D printing manager, because you will need a particular pool that is called, it's the material that fits in, and make sure that the 3D printing machines are actually working. No? But this is basically the file that you will be 3D printing. All of the steps from this point on is more like managing the machine through the manager of 3D printing. Okay. Good.